Well, welcome back. This is section 1.3 on measures of center. Our goal for today is to be able to determine the best measure of center, but also know how to do each of them. So to this point, we've been learning about graphical descriptive measures, and now we're going to kind of transition into some different numerical descriptive measures. So there's really three types of them, and those three would be the measures of center, which we're going to talk about today. You might see me abbreviating these as MOC. There are measures of variability. Also called measures of spread. And I'll oftentimes abbreviate it. And there's also measures of position. And we'll be getting into all three of these. Today we're going to focus on measures of center. So with this goal of determining which measure of center is best, we want to know what the three types of them are. They're called measures of central tendency, abbreviated as measures of center. So those three, of course, if you can recall, are mean, median, and mode. So we're going to look at data and be able to find those and kind of talk about some of the characteristics of each of those today. So I'd like you to take a section of your notebook, maybe half a page, and make a little chart like this, where we're going to talk about each of those three, mean, median, and mode, and really dive into each of them. So I'm going to give you a definition, how common they are, like if they always exist, and then some key points. So let's start with the mean. The mean is actually the most common one that we're going to use. I'm going to give you a little formula. It looks like this. And what that means is, that is the summation sign. So we're going to add up all the values. We're going to divide them by the total number of values. How many there are. And that'll get you your mean. It's a measure of center that's also called the average, but we're going to be calling it the mean. This one is the most common. The most commonly used measure of center. And it always exists. No matter what data set, you can always find an average. A couple notes about it. It's impacted by how many numbers there are. How many data values there are, so that's n. It's impacted by n, and it's also like greatly impacted by outliers. And we're going to get into talking about outliers and how they affect things and how that moves the different values over. But they are greatly impacted by outliers. All right, median. Median is probably the next most common measure of center. It is the middle. We've done this one before, but it is the middle of an ordered data set. As long as it's ordered in least to greatest, you can find the middle, and that's what the median will be. I would say it is fairly common. The middle or the median will always exist. I know sometimes it's not a specific value. Mean oftentimes is not a specific value. It's just the average. But the median is sometimes a specific value, but if there's two medians, you just find the average of the two, whatever's in the middle of the two. It is not impacted by outliers. And that, when it's not impacted by outliers, it's called a resistant measure. It is resistant to outliers. And then lastly, the mode. The mode is the most frequent value. It's not the most frequently used measure of center, but it is just the most frequent value. in a data set. But it's pretty rare that you would use this to talk about like a measure of center. It sometimes exists. I gotta say sometimes because if all the values are only on there once, there's no mode. I mean, there's technically all of them are the mode, but that means there is no mode. Sometimes there's more than one mode. If there's two of them that are both shown 5 times, there's 2 modes then. A couple of notes about the mode. I might go out of this box a little bit. It's useful for bimodal. If you have bimodal data, we're going to use the mode. Oops, I definitely spelled that wrong. It actually is a data value. So it's one of the actual data values, whereas the mean and the median aren't always an actual data value. And there could be no mode, or there could be multiple modes. So just worth noting, there could be no mode, or there could be multiple modes. So this is kind of some basics about the 3 types. Couple other things real quick before we actually do this. You're going to hear the terms statistic and parameter. You'll get used to this. A statistic is a value that comes from, a sample, whereas a parameter is a value that comes from a population. So a population could be our entire student body at this high school, whereas a sample could be from one individual class or several individual classes. So it's a smaller sample of the greater population. And I spelled population wrong. There we go. Now, the way I remember it is statistic starts with an S, sample starts with an S. Parameter starts with a P, population starts with a P. So you'll start to get used to that. But when we're dealing with sample data, and again, that's from a sample, it's a statistic, there's different symbols versus if we had dealing with a population data. So sample data, the mean is often referred to, actually it's always referred to as X bar. That's how you say it. Okay, that is the mean for sample data. Standard deviation is just S. And a proportion, which is another type of statistic that we'll get to, is P hat. It has a little rooftop on the top of it. That is called P hat. And we'll get to that later on as well. Whereas when we deal with population data, it's oftentimes a Greek letter. And for mean, it is mu. So it's like a U with a line attached to the front of it. Okay, that is mu. I think of the Pokemon Mew if you're a Pokemon person. But it's mu. Sigma, which kind of looks like this, is for standard deviation. We'll get talking about standard deviation coming up as well. And for proportion, it's just lowercase p. All right? Those are our symbols that we're going to be using depending on if it's a sample or a population, statistic or parameter. So I'm going to have you guys pause here while you find the mean, median, and mode for each data set. There you go. All right, I have them all listed here. Mean, you have to add them all up. For part A, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. You have to then divide by 9. For part B, I think there's only 8, so add them all up and divide by 8. For the median, you'll have to put them in order from least to greatest first, and then pick the middle number. If there's two middles, you find the average of those two. So that's what you had to do in part B. It was between 58 and 60. And then for the mode, you're finding the most common. And if there is no most common number, they're all just there once. You can say there's no mode. Okay. Now, when we're looking at distributions of data, we've talked about these different types of distributions. But depending on what the distribution is, the mean, median, mode might be in different places. So let's start with a basically normal one, kind of that bell curve. For here, the mean, the median, and the mode will all essentially be in the same place. Okay, I am going to color them, but you might not have different colors. Mean, median, mode. They all fall right at the same spot if it's actually like basically normal. Whereas a uniform distribution, which kind of looks like this, you've got very flat. Also, the mean and median end up at the same spot, right in the middle. Mean and median. There's nothing that moves them. Whereas the mode is all the same. So you can say they're all the mode, but really that means there's none, because they're all the same. So mode would be different for a uniform one. Going down here, what if it's a bimodal? So one of those M-looking things. Now with this, the mean and the median are also going to end up in the middle, again. So the mean and the median. But there's actually, oops, wrong one there. Wrong color. The mode will be at each of the two bimodal parts. So this will be where that mode is. There's two modes for bimodal. Now what gets a little bit interesting is the non-symmetric ones. The ones that are not symmetric, skewed left or skewed right. So let's just look at here's my example of skewed left. There's my skewed right. Now, not perfect drawings, but you can get the idea. Just a reminder, mean, median, sorry, that's mode, wrong color, median. Where the highest value is, that is still the mode, okay? So the mode is still at that highest value. But the median, if it's the middle number, it's going to be a little bit off to the left a little bit or off to the right, kind of in the direction of that skew, but not too much. But you can guess it's going to be kind of off to the side of that, because that'll be more the middle value. But the mean is the one that's really pulled by a skew. So like you have a whole bunch of values in the 20s, and then you get this one that's 500. That's going to pull it way higher than it actually is. You get a bunch of test scores that are 90%, and you're like, oh, the average is going to be 90. But it's really like 80 because someone got like a 50 on it. That really pulls it down. Whereas the median would still be around that 90. And so would the mode. So the mean is the one that's most pulled by skew. And that's why sometimes you see or hear of trimmed means. So a trimmed mean is where you remove a certain percentage of the largest and smallest values before calculating the mean. It's best suited for data with really large or erratic deviations or extremely skewed distributions. So those skews or those outliers, that's maybe when we'll use trimmed means. You oftentimes see it with reporting economic data, because you have a lot of people like in this certain area of wealth, and then there's some people who make no money, and there's some people who make obscene amounts of money. So you cut off the top and bottom ends, and you get a better idea of where that center is with the mean. So I have some data here. This is actually the number of murders in each state from 2017. Real exciting stuff. If you actually added all 50 of these up and divided them by 50, you would get a mean of 302.56. So you'd say on average, each state has 302.5 murders per year. But if we were to take off the top and bottom 10%, try to cut off some of those highest and lowest values. So if I know there's 50 states, 10% of that is 5. So when you find a trim mean, you will essentially cut off top and bottom 10%. Or if you want a 5% trim mean, you do that with the 5%. But we're going to take off the top and bottom 10%. That means it's getting rid of the lowest 5 and the highest 5. And we're just using all the data in between. If you find the trim mean, this mean is now actually 241.25, quite a bit lower. That's like over 60 murders less just by finding the trim mean. And that might be a more accurate way to estimate the number of murders per state. All right, so that's just another option with means. So I want to just do a quick recap. 2 questions. One, does the measure of central tendency exist in the given data set? Always, sometimes, or never. So with a mean, there's always, we talked about this before, there's always going to be a mean. There's always going to be a median. And there's sometimes going to be a mode. Sometimes it's no mode or they're all the same. So we say there's no mode. Okay? And which measure of center is best for different situations? We kind of talked about that as well. But I will say mean is best when it's symmetric. It's the most common, but it's best when it's symmetric because it is non-resistant. It's considered non-resistant to outliers. Whereas the median and the mode are both resistant. The median is then very useful when it's non-symmetric, but it's also going to work for symmetric. So I'll say or symmetric. But most importantly, if there's an outlier. And the mode is just typically used when it's something that's bimodal. It's not super common. It's also kind of used for qualitative. If you're dealing with qualitative data, something that fits into categories. Like this is the most to have the favorite color of blue. Too many things there. But that's then when you talk about the mode. So those are our measures of center. Those are the basics of our measures of center, and that was lesson 1-3A. See you next time.